Welcome back, engineering design students. Today we're going to be learning about LCDs or liquid crystal displays. And that's what this kind of watch display is. It's a liquid crystal display. What that means is there are crystals in very specific spots where you can turn them on, such as in this 3, you have 1, 2, 3, 4, 5 turned on, and you have 1 and 2 turned off, right? Where with this 8, you have all 1, 2, 3, 4, 5, 6, 7 crystals turned on. And that's the only thing you can do is you can turn crystals on or you can turn them off. You can't do anything else. So I can't make a triangle, right, with a liquid crystal display unless I put things in triangle shape. So with a liquid crystal display, it's pretty much you can only make anything you can make out of an orientation of 8, 7 crystals in that can make a figure 8. So anything you can spell with that is pretty much what you can do. If you look up here, you'll notice that they have included a bonus one right there so that the N has a little end to it. Isn't that nice? And clearly they've set it up to where this could be an M, right? Because we see that right here. So there's different liquid crystal display elements here than there are down here. And I'm going to share this document with you, which takes a liquid crystal display. It's a 16 by 2. There's 16 spots across. Each one could show an 8, right? And there's 2 rows. So it's called a 16 by 2. And I have what each pin does. So here are the pins. There's 16 pins right there. And I have them labeled here and what each one is. But I would like you to build this along with me. So we're going to go to Tinkercad and we are going to start a brand new circuit. So let's go to circuits and let's create a new circuit. Now I'm going to open one that I've already created because I have some stuff loaded, some code loaded, but you're just going to click on create new circuit. So let's do a new circuit. You are going to end up with a blank screen when yours shows up. So then you'll want to put Arduino in, and you'd want to drag an Arduino in. Now, I don't want an Arduino in mine, so I'm going to delete that one. Yep, that guy. Yep, you can kill that code associated with it because my secret code's right there, and it's for this Arduino. Okay, so you are good. Now, while you're building your circuit, let's put that up and over there. Let's put an LCD into. So I type in LCD, and a 16 by 2 LCD pops up, and we're going to put that right below the Arduino and kind of position them so I can see the whole Arduino, I can see the LCD. Now, note, when it comes out, this is the exact orientation I want, so just leave it like this. But if we look at here, you'll notice that the pins here are on the bottom right and the pins here are on the top left. So this, what I'm going to be going through is actually a rotation of this. So I have mine set up so that you can see the pins and you can read. So mine's set up that way, and this is the easiest way to lay it out. But if I hit R a bunch of times, this is the exact layout of this. So you're gonna have to kind of twist things in your mind a little bit, but I believe in you and your ability to do that. So let's just put this back. Here we go. Let's begin. Okay, first thing I see is let's go with pin 1. Pin 1, VSS. VSS is the electrical term for ground. You connect this to the ground on the Arduino. And in fact, if I even come here and I go to pin 1, which would be up here, it even says ground. So let's do that. Let's take this and connect it up to ground. So any of the grounds work. You could technically do it here, but then you're going to have a lot of wires coming out of here, and it might get kind of hard to manage. So I recommend putting it up to one of these grounds. And the second pin, so 1 goes to ground, 2 is VCC, which is the electrical term for power. You click this to the positive terminal. This is where the electricity comes in. So I go to the second one. Hey, they even listed it as power for me. And I connect that up to 5 volts on the Arduino. I'm going to hit number 2 so it's red, so I remind myself that power comes in through this wire and it goes out through this wire. And these 2 wires are going to power up the entire LCD. So that's going to let it read data from the data ports. It's going to let it manage itself, like power itself up. Now the individual crystals here, as in the 7 crystals that are lit here and the 5 crystals that are lit here and the 2 crystals that are lit here, have their own power. And they're way at the other end. They're actually numbers 15 and 16. If I scroll all the way down, I see that 15 is the power for the LEDs, for the actual crystals. So these crystals have a different power than the entire face of the watch. So the entire face, to be able to decide what to do, needs its power, and then the individual crystals need their own power. So the power comes in on 15. So I'm going to come back here. I'm going to go out to 15, which, hey, it says anode. Anode. Hey, I remember that from LEDs. That's where power goes in. So not the last one. That's the cathode. One in from the last one, the anode. I'm going to click on that. I'm going to take that right up to 5 volts also. So this powers the whole screen. This powers the individual cells that will build the words and numbers that I'm going to print. And this last one I saw, it says cathode. Hey, that's the out for LEDs. And since this is made out of LEDs, I'm going to ground that too. So again, you can choose any ground. I'm putting them all on the same ground. And this powers the whole screen. This is the out for the whole screen, the return, once the electricity is done doing its job. This is the in for the individual crystals that are going to show the words. And this is the out for the individual crystals that are going to show the words. So we have now powered, and you'll notice that they're at the ends. That's a very normal circuitry thing to have all power kind of handled at those end pins. So now we're going to start looking. Now if I zoom in here, you'll see that there's D0 through D7. So there's 8 pins here. 8. Oh, 1 bit of information. A bit is 1 byte of information. A byte is 8 bits. So this is where the information is going to come in. That is the last thing that we are going to wire. So we are going to deal with whatever VO, RS, RW, and E are all about. We're going to wire these 4 first, and then we'll deal with the data. Okay, so first let's find out what all that junk means. So I'm going to get this back to where I can wire it easily and then come back here. So we have done these 2 pins, 1 and 2. We've done these 2 pins that light up the individual crystals, and now we're going to go to pin 3, VO. What does VO say? Contrast control. Oh, that's how bright the display will be. Now, ultimately, at the end of this video, we're going to put a potentiometer on there so I can change the brightness. But just to give us that first look at it and to have as few moving parts as possible, we're just going to put a resistor in to give us the right brightness. So what I'm going to need here is I'm going to need a resistor. So I just, not you, silly computer. I'm going to take a resistor. I'm going to bring it out. And this resistor needs to be 470 ohms. So 470 ohm resistor will give us the right brightness. So I'm going to take that, I'm going to attach that right to VO. So we have 1 is ground, 2 is power, 3 is contrast. And then I'm going to attach the other end of that, the terminal 2 of this resistor. Terminal 2, I'm going to put that to ground also. And that is going to, didn't quite take now, did it? There we go. Nope, I'm having some issues with my mouse. There we go. And that's going to decide how bright it is. So we're not going to be able to change the brightness right now because we're using a resistor. Ultimately, we'll put a potentiometer in there and be able to make it brighter or darker. Okay, so we have done the first 3 or 4, where the characters will display on screen. That matters because we have line 1 and line 2. And also, I may not want to start right here. I may want to start here. So the RS is something that the Arduino is going to have to tell the LCD. Hey, start at the top left or start at the bottom and 4 cells in, whatever. So the RS is something that we are going to have the Arduino tell it. So I would say let's put that into pin 1, and then we'll just have the Arduino later on tell it. So I'm going to take this, I'm going to put it right into pin 1. And then later on, I'm going to code the Arduino to say, and let's change the color so we don't think it's power. We'll put it to green. This right here, the register select, says where we want to print it, and I'll code it so that the pin 1, the Arduino knows to send that information out pin 1. Okay, so RS is attached to pin 1. Gotcha. And you should be following along, so you should be pausing the video, wiring your own, starting the video back up. Okay, now 5 switches between read. That would be if you're going to use your LCD as an input, or write if you want to write to the LCD. We want to write to the LCD. Now the way this is wired, the way pin 5 is wired is if it's powered, then it knows it's an input. If it's grounded, then it knows it's an output. So it's just an on or off. It's a switch that goes between them. We are going to write to ours. We're not going to use it as an input. We're going to use it as an output, like a screen. So we're going to attach our pin 5, our RW, to ground, and that tells the screen, hey, you're just printing out stuff, you're not an input. So we go to RW right here, read write, and we attach that to ground also. Wow, our ground is getting busy. It is, and this is a simulator, so we can put as many as we want. If you're actually wiring this, you'd probably put a couple in this ground too, just so this pin doesn't get overloaded, or you could even use this ground. Or you'd really use a breadboard, which is a normal way to do this, but I didn't want to deal with breadboards. So we have done 1 through 5, and 6 is enable. Alerts the LCD that command is coming and wakes it up. So an LCD just kind of sits there until it's told to do something. So it kind of like leaves itself on, and then when you're like, hey, new information is coming, you have to like wake it up to listen to its data ports. So you have all these data ports, but the data ports are just hanging out there, right? So the first thing you do is you send an alert saying, hey, data coming, and then the data ports kind of wake up and then they manage it. So the first thing that the Arduino is going to do is it's going to power up pin 6 and say, hey, data's coming, and then it will send the data. So we have to attach this to a port on the Arduino and then tell the Arduino that that's the wake up button. So I'm going to attach mine to 2. I'm going to attach enable to pin 2, and then I'm going to, let's have that, I don't know, I think green also, sure. And then I'm going to code the Arduino and tell it, hey, pin 1, you're going to say where to print stuff. And pin 2, you are going to tell the LCD when new data is coming. And you could choose any pins for these. I'm just choosing 1 and 2 myself, but you could choose any of these pins to do any of this, because this is completely programmable, this chip right here. You just have to tell the chip which to use, and then it'll just do it. It doesn't care. And now we are to the sweet spot. We are to the data. Now, what we're going to be sending is really lo-fi stuff. So we're actually just going to use half a byte. We're going to use the back 4 data ports. We don't have to send a full byte. If we wanted to send a full byte, we could. We could use all 8 data ports, but we are just going to send the last 4 data ports. So now I have to remember which pins I used. I used 8 through 11. Thank you. So now what we're going to do is we're going to connect pin 4, and I set mine to 8. Pin 5, I set to 9, pin 6 I set to 10, and pin 7 I set to 11. Now again, you can code your Arduino so that it uses any of these ports, right? 0 through 13. They're all completely usable. You can program all of them, right? I just chose to use 1 and 2 and 8 through 11. That's just my choice. Now, if I've wired this correctly and I hit start simulation, hopefully something will happen. Oh no, I blew it up. How did I blow it up? Oh wait, these are LEDs. Silly Jay, you can't attach an LED straight to power. You need a resistor, you fool. Okay, I'll put a resistor on. And what size resistor do LEDs like? A 220 ohm resistor. You silly cat. So we attach that to the either anode or cathode. I just chose cathode, and then I'm going to attach that back to ground, change it over to black. So, hey, these are actual LEDs because I had the exact same issue I would have had with an LED if I didn't put a resistor in. And now when I hit start simulation, this code that I wrote, what's that code? Show it to me quickly. I will. That's the next thing we're going to do. It shows hello world. So I've printed it to do hello world. I've made that setup. Now the last thing I want to do is quickly burn through these pins, then throw a potentiometer in. So let me put this potentiometer in, and I'm going to do it over like this. That's for later. Just quickly walk through these pins and how I've wired them. Okay, pin 1, ground. That powers the whole screen, or is the out for the electricity in the screen. Pin 2, that powers the whole screen. That's the in for the electrons in the screen. Pin 3, what's that? Oh, that's contrast. That decides how bright it's going to be. So I'm going to be replacing this resistor right here with that potentiometer I just dropped in so that I can change the contrast. Pin 4 is register select. That is, where on the screen are you going to write? Pin 1, I've programmed it so pin 1 will tell it where to write. Read or write, right? Pin 5, read or write. If it is attached to ground, it is a screen. If it is attached to power, it is an input. We are using it as a screen, so we see a black wire attaching it to ground, so it's an output. Enable, that wakes the LCD up and tells it, hey, data's coming, get ready for it. I've coded it so that pin 2 will power that up. These pins, not using, because my data is so small I don't need a whole byte. These are the pins that I'm using, and I've told the Arduino use pins through 8 in order, so that's going to be the first, second, third, and fourth pins to send data down. This is the power in for the individual crystals that light up. This is the power out for the individual crystals that light up, and I've decided to put the 220 ohm resistor on the out, though I could have easily put it on the in, and that would work because these are LEDs and it doesn't matter if the resistor's before or after. Okay, that was a nice speedy look at that. Now let's look at this potentiometer. Now the potentiometer is going to divide voltage, so we're going to use it as a voltage divider. That means we're going to use all 3 pins. And, oh, I got to shrink it just a little bit. There we go. And it's going to replace this resistor. So let's click on that resistor. We are going to be playing with contrast. Well, if I remember anything about a potentiometer is, this is the off setting, this is the lowest setting, and so that is the out, that is the ground. So I'm going to attach that to ground. The pin that is closest to off is ground, and the pin closest to on is power. So I set those outside pins. This one is power because that's the full volume. If I turn it all the way up, it's going to be powered fully. If I turn it all the way down, and this is turned down, it would be off, so that goes to out. And then this is the resistance that it gives. So we are going to put that with which pin? The contrast pin. So that again, that is pin 3. So contrast. So just clicking into contrast, and that third one will change the contrast. So now, if I let's just let's zoom in just a little. My zooming isn't super awesome on this. Sorry. Oh, come on. I'm trying to zoom here, people. Now, if I hit start simulation, I should be able to mess with the contrast. Oh. Hello, world. No, hello, world. Hello, world. And with a little, I can just mess with it just a little. There you go. Oh, that's not very bright at all. Okay, so the potentiometer is optional. You don't need it at all. In fact, I recommend people not using the potentiometer. You can, I just wanted to show you. I recommend people using a resistor. Again, that's a 470 ohm resistor. I find, if you want to mess with contrast, you can. There's no real need. I would use a resistor instead, and that would connect the contrast to the ground. That way you don't have any dials to work with, and it will just work. That's all I got for you today. Hopefully this is completely wired perfectly, and then there'll be a homework assignment where you will have to tell me what each pin does. You'll have to write a number saying what each pin does attached to this homework assignment. That's all I got for you. Good luck.